Hello, everyone, and welcome to 8LU. Welcome to 8th Light if you haven't been here before. Glad to have you. Today, we are lucky to have in our presence the creator of Ruby Kickstart, former 8th Light, current Turing School and Code Platoon leader, teacher, and Craft Shark extraordinaire. Yeah, that's it. Josh Cheek. So everyone give him a warm welcome.
You all can keep on. Cool. Greetings. It's a pleasure to be here. I've got a talk today called the Ruby Object Model. And I feel like something like that sounds very sterile, so you got to market it a little bit. Hence the matrix image, which I don't know if you can read or not. But if you can't, good news, this is all online. And you can get the material by going to github.com/joshcheek/that thing, which I should have made that shorter probably, but you can also just go to Josh Cheek, click repositories, and it will be on top. Independently of that, I found this thing that lets you make like ASCII art, and so it also looks cool like that, but nonetheless. So I think my approach here is going to be, I numbered them because I have ADD, and so I figured if I have a number, I can just like count, which I can do. And so as a consequence, we can just go down from the top, and then some of these we'll kind of skip. They're there if you are curious enough to go further into the material. So the approach that I'm going to take is to start here with like section 3. And we'll look at all of these at once, and that'll be basically the object model. All right, it's just those 3 right there. And then all the rest of this stuff is like contemplating the implications of those 3. Okay? So I'll talk a little bit about like what comes out of that, and then I'll kick you all off to try and do some challenges on your own, and then we'll come back and I'll like answer a handful of them, explain the solutions, and then assuming that I don't mess up all the time, am I allowed to use profanity here? I just censored myself. I was like, mess up. I am? All right, delightful. Assuming I don't fuck up the timing, we can come down here and talk about modules and Singleton classes. And then there's just like a whole bunch of extra stuff, like if this is blowing your mind, you can go explore using these things. So the first thing to address is, who is this talk aimed at? And the answer is intermediate to advanced Ruby developers. I debated on that one for a while. Like, do I want to ooh, that was tricky. Do I want to try and make it consumable for people with less experience? And I do frequently attempt to do that, but there's a certain amount of time that gets lost with convincing people to believe the world is really like this and not like syntactic patterns that they've memorized. So I'm hoping that if I can like communicate these ideas to people with more experience, then it'll trickle down, but like it'll work better in this case, hopefully, than in politics. I'm calling it the object model, but you can also just say, like, how does Ruby work? Like, if you get these situations where you're looking at some code and you're like, that makes no sense. I have no clue how to even figure anything out here. The good news is you can always just understand mechanically how everything works, and that's what we're going to discuss today. And then, of course, things emerge from the mechanics, which is where it gets interesting. Basically, everything within Ruby will 95% of what you need to know in order to understand how things work in Ruby. Unless I fail, in which case you get like none of it. Thank you. Amusingly, you can see I fucked up the bullet points there. But it kind of works out. Like, yeah, it lines up nicely as well. So I'm going to say that was a plan. Here's another question you have to ask, or I guess you don't have to, but there's another kind of question that I ask, which is, what is Ruby? So as a consequence, I'm going to show you things, and these are the same as the inside of your web browser works. And you could say like, well, what is the DOM, Josh? And the answer is it probably changes if you're in Chrome versus Internet Explorer versus. So in some regard, it's an idea, and a couple of choices that I make in here are based around what I think is easier to understand more so than like what is the actual quote-unquote truth. Which allows me to explain that I'm going to show you some hashes, and underneath the scenes, you could implement them as hashes. I've done this in the past. Or MRI, the Ruby that you typically use, is going to use what we call a struct, which, if you don't know what that is, you can just say that's probably like a hash, and that would get you pretty far. Okay. I'm going to try doing this all in the browser so that the colors don't change out from underneath of you. But if it doesn't line up well, I got it in my editor here too. All right, we'll go like this. All right, so these are the three structures, assuming I can fit them all on the screen, that give rise to all the complexity you see in Ruby. Oh, wow, I didn't even know that would happen. Can you read this right now? Okay, so then you'll just believe that anything I say is true, and that's probably what's on the slide, right? Okay, we'll go like this, then I'll go back to my editor. I feel like that'll work better. How about this? I'm going to delete some comments, and that will hopefully help. Can you read that right now? Okay. I'm way better at my editor when I sit down, so I'm going to just sit for a minute. There we go. All right. Probably it would work best if these two are swapped, but I'm just not even going to try that, unless you just want to watch me fiddle with getting them on the same screen for another 10 minutes. So I've got three structures here, and to some extent this is my interpretation, and to some extent this is totally truth here, depending on how you want to look at things. These are the structures of objects, like the data structure that sits underneath of an object, the data structure for a class, and the data structure for what I'm calling a binding. And we can ignore this one for just a minute, and we'll just talk about objects, and then we'll go to classes, and then we'll talk about bindings, okay? So there's a lot of like questions that you would have when you're new, probably like what's an object, how do they work, etc. And at the end of the day, I could think of like probably like 5 different explanations for what it is, but let's just talk about the structure of an object. It's got 2 things, a class right here, and a class is going to be one of these things. It's going to point at one of those things, and it has instance variables, which is also a hash. The keys in this hash are symbols, things like, @username, and they're going to point at something like some kind of a compiled method object, like that, okay? And this is relevant because in order to have a programming language, you really need 2 things. You need data so that you can represent nouns, and you need methods, or not methods specifically, but some way to operate on that data. And you could call that a verb if you wanted to. And the class is what allows us to find our verbs over here. So the purpose of the object is to store the data, and the purpose of the class is to store these methods which operate on the data. All right? Okay. That'll get you like super far, because that's basically all that's available in C, is just like a function and arguments. And so your arguments are your data, and they store them in like structs, which are basically hashes-ish. and then your functions sit over here. Ruby's a little bit more sophisticated. Since every object has its own set of instance variables, every object is a container for a piece of data. And the methods over here, what we wind up wanting to do fairly frequently is share them across several classes. So there might be different types of objects that can each do the same thing. You can imagine like the toString method. You would want that to be generally available on every object so that if you don't define it, you have one by default. And the way that a class enables that kind of behavior is through this one right here, the superclass. So an object plus a class's methods and superclass are like the core of how things work. Oh, I'm totally messing this up, aren't I? That goes there. Thanks for, I'm going to assume that people knew that and they're like, well, let's see how far you go. So this thing This thing here has got data, the instance variable, and this thing here is code that you can access based on its name. And if you don't find the thing that you're looking for, you look in the class for then what you're going to do is you're going to come to the superclass, which is another class, and so therefore it's got another method that you can go look at. So I got my data, and I want to work on it, so I want to call a method on it. I'll go to the class right here, which will take me to some class that has some set of methods, and if I found it, then I'm good. I got to go to the superclass to look at those methods, and if I didn't find it, then I got to go to the superclass to look at those methods, and if I didn't find it, and on down the line until you eventually hit the top, in which case it will explode, say no method error, which I forget. Okay, so that's the core of it. Turns out, because we're trying to explain like a massive amount of Ruby here, classes also have another key called constants. And inside of that key, that key is a hash. It's pointing at a hash. And so your keys are going to be things like the symbol, I don't know, string. And the value would be object, in this case, the string class. And so constants are stored on classes, methods are stored on classes, and instance variables are stored on objects. In order to enable you to call methods on objects or on classes, we also give them the keys that objects have. So that means a class and instance variables. And as a consequence, a class is also an object. But I didn't want to put that in there, though, is why it says also reference the other one. Because if you mix them all up, then it's super confusing, and you can't keep anything straight. To go where, and then I would just use my acronym to figure out how to call the method. But then what I realized was if I just keep these two separate from each other, there's a really elegant way to think about these two, which some of y'all might have figured it out already. If not, I think I mentioned it in one of the next bits. All right. The last thing we need is the binding here. And binding is a word that I kind of picked. Really, I'm kind of describing a couple different things with this one. But if you come from another language, you might have called them scopes, or you might have called them stack frames. And the binding, what its job is to do is to take the code from the method, which is sitting in the class, and so it doesn't know what object it's working with. And the binding's job is to essentially allow that code to know that I'm operating on some particular object. The way that it does that is with self. So because the binding has a self, the method knows where to go to get instance variables. If it calls a method without explicitly stating a receiver, then it knows which object it called it on, simply whichever one's right there. And the binding also is where we store the local variables. And anytime we have things that are named, you can just, if you have a bunch of names, you have a hash. Okay? So anytime you have anything that's named, a collection of variables, you have a hash. So when we say constants, that's stuff with a capital letter, hash. We have methods, a bunch of data stored by their names, so that's also a hash over here. And we have instance variables, a bunch of stuff that we're storing by name, again, a hash. So if you keep that in mind, that'll get you like super far in terms of like simplifying your world, or at least your Ruby world. These ones here, this is my interpretation of it. The binding is where we're going to store the value to be returned. So when you call a method and it returns a value to you, we're going to store that here in the binding. And every time we evaluate an expression in Ruby, it evaluates to some object. And every time we do that, we'll just update whatever that value is right there. So as a consequence, if you evaluate a piece of code, you've updated the return value. And then if you leave the method, you can always say, and what was the return value? And you'll just look at it and see that thing. This is why, for example, the last line of a method is returned. It's because it's the last thing you evaluated, and so it's what got stuck on the binding's return value. And so when you popped it off the binding and you looked at it, you see that value. Next binding here is because this structure is a stack, and when we finish executing code in our current context, we're going to want to jump over to wherever we came from. And that's what next binding is going to store. Instruction is where in the code are we currently located. So if I'm running, I don't know, say add like a plus 1, a plus equals 2, whatever it is, I'll jump over here. All right, can you see that? All right. So we can see here, we're gonna simplify slightly, and we'll say that each of these is a single atomic expression. And what needs to happen here is we need to know that I'm on line 1 right now. All right. So we will execute that one, find 0, and update the return value in the binding. So if we left right now, the return value would be 0. And because the instruction, that thing that I named instruction, it's sitting there saying basically line 1 in our case. Because we've implemented that one, we've run that code, it's going to increment to number 2, and then we'll go here and we'll look at that one. And as a consequence, we'll see 0 plus 1, or 0 plus 1 is 1, yeah. And now that instruction is sitting there saying number 2. Okay, that's that one right there. And then we'll go on from there. It'll increment to 3, we'll see that one. And finally, it'll increment to 4, and we'll see that one. So the instruction there is keeping track of where we're at in the code. Self, in this case, is pointing at some object. In this particular case, that object is main. That's a little bit magical, but we'll explain that too. And local variables here is just a hash, and we can see I've got one local variable in there. It's the local variable A. And Ruby will give you methods that will let you ask questions about stuff like that. Despite the name, this only returns the keys, not the whole hash. And so we can see that it returns the symbol A, because that was the key inside of this local variables hash right here. And finally, I've got this one here called env. And what this one does is allows you to go look for other local variables if you can't find yours, such as a block. I don't know, we'll say string. Okay. So in this case, there's a separate binding right here, and it's got a local variable named char. And so when it looks up string here to find the value that we're adding it to, it's not going to be able to find it in the current binding. And so what it needs to do is be able to say, well, where was I contained, or what other places can I go look for this local variable? And what we'll do is we'll set this end right here to point at the binding of this kind of outer context where we're storing the string. Just string. But if we look in here, we've got, it got called 3 times. That's why we see 3 results. Char and also string. So that one's through the end key. All right. Anybody have questions on this? I'm gonna jump to the next step, which says like what kind of, we're already starting to get there, which is like what sorts of things come out of that, right? Like what does that enable? How does Ruby emerge from these 3 hashes? But I want to make sure to address a question if anybody's got any. Okay. All right, just a few caveats before I go on. If you want to see the C implementations, I've got links right here. My binding is a little bit simplified. If this is all fascinating to you, there's a book called Ruby Under a Microscope, which goes into a lot more detail than I do. And I didn't talk about any of these things, so they're not explained by this talk. And there's probably a few other things I didn't think of either. Okay. So now we'll get to talk about the class of an object and the superclass and methods over here. And this is like one of my favorite things in Ruby, I think, because it winds up being incredibly elegant. Get rid of that thing. So if you're familiar with a linked list, right? A linked list typically looks something like this. You've got the base of the list, which is keeping track of the first node in the list, and that's frequently named something like head. And then the node is a structure that contains a piece of data that you're looking for and a link to some other node in case you can't find the piece of data you're looking for. So these 2 things are how you would implement collections. This is one way of implementing a collection in a language where dynamically changing the size of an array isn't available to you, such as C, for example. There's any number of ways you could do it, but this is one way. And so if you've thought about linked lists or you're familiar with them, then what you'll notice is that our object has a class, which is where it's going to go to find its methods. And a class has methods, the thing we're looking for. And it has a superclass, which is the place to go to look for more methods if you didn't find the one that you were looking for here. And if we analyze the structure of this thing, what we discover is that they are the same. And so inheritance in Ruby is actually implemented through a linked list. So everything that you know about how to reason about linked lists, you can use to reason about method lookup in Ruby. All right, I got a little piece of code here. We can see that I'm able to set the instance variable ABC to some very important value, such as 1, 2, 3, and later on, if I look for it, I'm going to find it. You don't frequently see it sitting here at the top level, but nonetheless, at the end of the day, there's just these 3 structures, and they don't impose limits on you, like make your code look the way that most code that you see looks. They just work. So I can always set an instance variable from anywhere. The question simply becomes, what am I setting it on? And the answer to that question, I should have totally left these in the situation I had been in previously. The answer to that question is they are setting them on whatever the current binding says self is. So in our case, it says that self is this thing called main. And so if I say, well, what instance variables are stored inside of there, it will go and it will look at that hash and return to me an array of the keys. This is an object, the thing with the class and the instance variables. And so when I ask for it, it tells me what's in that hash right there. And I get ABC back. You can notice before I do that, there's not going to be anything in there, because that didn't get set into that hash until I hit this line right here. If I go into some other object, such as if I open up a class, well, now self has changed, so I have a new binding on the stack, another one of these things over here, and the old one is still sitting here. The old binding is still sitting there where it used to be, but we stuck another one on, set its return, where is it at? Its next binding to be the one from main, and then we set the self in the second one to be our class A in this case. So when I did that, I got a new binding, self changed, and so if I look at the instance variables at this point, I have none. Of course, I could set an instance variable in here. I don't know, somebody pick out a noun for me. Four? I'm going to go with 4. I'm going to call it a 4, and I'm going to pick that as the value. So now, if I look at my instance variables, the question becomes, is that one going to change? Am I going to see at 4 in there? And the answer is going to be no. You probably couldn't see that, but it was a no. And if I look in A, well, what instance variables does that object have? What we're going to see is it's got the instance variable 4. Okay. So because self changed inside of here, when I set an instance variable on it, I was setting it on what that self was, which in this case is the class A. And it stays in there because that object's still around, same hash as before. Let's talk about calling a method now. Whenever you have a method invocation, something like this, expr means like some piece of Ruby code that can be anything really. And then we invoke a method whose name in this case is method name, and I give it 2 arguments. The question is, how does that work, given that I'm asserting all of Ruby comes out of these 3 structures? First thing we're going to do is run this code to see what it evaluates to. Second thing we're going to do is go run these 2 pieces of code to see what they evaluate to. And now I know what I want self to be in the binding to run this method. And I know what local variables to set inside of that binding as well. This is too sterile of an example. Let's somebody else pick out a noun, and we'll do that one.
Chickens.
All right, chickens. All right, so I got this chickens method here, and it needs some arguments. I like this area over here. Hook me up with 2 more nouns. All right, crash shark. Patrick, there we go. All right, we'll stick that inside of, I need one more noun. We'll do one from this side now. Somebody on this side, give me a noun. I'm gonna throw things, and whoever, potato? Okay. All right, so we got a potato, which of course naturally has the chickens method that receives the craft shark and the Patrick. All right. I'll name it a potato. It seems like let's name it a tomato. All right. People don't normally do this, and I think it's important to see this because normally it's named potato, and that's potato, and it's like, are they allowed to change? Why are they the same name, and so forth? And the answer is simply it makes more sense for them to be the same. Like if I looked at a thing called tomato, I'd expect this to be a tomato. That's kind of confusing. So as a consequence, people don't really do that. But if you're just interested in how do things work, a local variable is what that is, and I can pick any name I want for it. And then this is just some object, and it doesn't really matter what it is. And so if you think about, in order to explain weird stuff like this, it helps to think about the structures. So I'm going to make a new tomato, and I'm going to call chickens on it. And it needs a craft shark and a Patrick. What's a good craft shark name? All right. And what's a good Patrick name? Paul. There we go. I don't know how to, we'll do one of these. I don't know how to get like a Unicode character, so we'll do one of those. So it's a Josh loves Paul. Now, if we look at this example here, you can see we're calling this chickens method. And this is like a less sterile version of what we were seeing right here a moment ago. The first thing we need to do, again, is figure out what tomato is. And so we're going to go look in our current binding, look up the local variable tomato, which came from here, and we'll get that potato that we made earlier, right? All right, so that's our potato. And now I know what object I want to call it on, and so I need the method name right here. And that's the thing I'm going to invoke later on, but I'm not going to go look it up just yet. First, I'm going to evaluate this argument and this argument. And in this case, they're very simple. They're strings, but you can imagine it could be something like, some other variable like that. I don't know. That's terrible. All the other ones are so much better. What was this? That was Josh. All right, I'll bring Doug in. Like that. So in this case, we got to go do a little bit of work. It's not quite so simple. We got to go find our current binding. This thing right here, look inside of its local variables where we see that we have a tomato and we have a Doug, and we'll find the value of the Doug, which is the string Josh, and then that right there is going to wind up evaluating to this string. For Paul, it's a little bit simpler. It's a string literal. So Ruby evaluates those two. It's got its two arguments, and it's got the receiver of the method. And now it's got to go find this chickens method. So what it's going to do is it's going to go look at the tomato, and in the tomato, it's got two things, the class and the instance variables. And we know that the class is where we store methods. And so it's going to go follow the class to get to the potato, where it will look for the instance methods, where we'll find that we have chickens. Okay? So that's the key in the methods hash right here. If it didn't find it, of course, we know it would follow the superclass link right there, and it would go look inside of, I think, object in this case. Okay. So if it didn't find chickens in potato, it would go look in object. And in this case, object is boring. It has nothing interesting in it. So let's get rid of it and bring potato back where we have the fun chickens method. So now I got my arguments here, the string Josh and the string Paul. I got my receiver, and I've found my method chickens inside of the potato class. And so the next thing I need to do is put another binding onto the stack. I don't think I've used the word stack yet. Stack is a linked list of bindings. Okay. So I'm going to put this new binding on, but you can see it's got a lot of stuff that it needs. We got to figure out what to set those to. We're going to set self right here to be whatever object, whatever our receiver was. In this case, tomato, the potato. I could say that like 5 times fast with a straight face. Tomato the potato. All right, so that's what self is going to get set to. Boom. And then these two arguments, those are going to get lined up with I'm going to use the phrase parameters here, even though most people use a parameter and argument interchangeably. So the string Josh will get lined up with that one, and the string Paul will get lined up with that one, and we'll just set those into the hash of local variables for that binding. Okay. We got a craft shark, we got Patrick. So that means I could look up the craft shark, and I would, of course, find the string Josh, because it got set right there, which was passed in from right there, which was looked up from the local variable that we saw set here, which was Josh. So the string Josh is the value at that local variable, And we've got the Patrick here. And we can see that Patrick is the string Paul. And so if we do craft shark plus loves plus Patrick, that will evaluate, it'll evaluate that line of code and set the results into the return value on the binding. And we can see that that's actually the last line of code. There's nothing else to do. And so at that point, we're done running the method. And we'll take the binding off of the call stack. I'm trying to think there's probably the best way I could show you. I'm going to skip it. Just in your heads, imagine that there's like the binding from out here, where we've got the local variables tomato and Doug, and the binding from in here, because we just called that method, where we've got the local variables craft shark and Patrick. Okay. And since I just evaluated that one, I get the string Josh loves Paul, and we set that into the return value, and then we leave the method, so we take it back off of the call stack, which means that we're back inside of this code. And its instruction pointer is sitting here on line 11 saying, you know, the next thing I run will be line 12 when I'm finished with this one. And that just kind of sat there and chilled for a bit while we went up here and did all this stuff. And now that we've come back, we take this return value and we stick it here as in our current bindings return value, which is why we see Josh loves Paul there. And there's nothing else to do. You can see that's the last line of code in here. And so this binding leaves the call stack, and there's no more bindings because this was the topmost binding. And so the program ends. All right, that's an example of method invocation. Think of classes as classes, but I'll just say that the fact that you can call a method on them means that they're also objects, which means that they have instance variables and a class right there. That's my fancy way of like not spending a lot of time on that slide. All right, so I think that those were like the core ideas, like a handful of like important ideas I wanted to express. I got a bunch of challenges here that you can kind of go through. It's going to be chaos, and that's going to be fun, for me at least, as I watch everybody like try to pull out their laptops and do some work. We'll see how it goes. If it goes horribly awry, then I'll just do them on my computer and talk a while. And if not, then I'll let you, then hooray, we will have succeeded. At which point, you can experience the frustration of the ridiculous examples that I made up here inside of the challenges. And then we'll come back in like 10, let's go for 10 minutes, because you probably want to go do the rest of your life, which I imagine happens in 2018. So we'll go in here, and let's say, based on what we talked about, how about look at, this might be fun. Let's do this one. This is a harder version of another one, but given the amount of time we have, I feel like this is the one that's going to be the most fun to do. It's called Super 2, inside of the challenges, inside of the material on my GitHub. And your goal is to basically predict what's going to come back from there. And if you get that one, go on to that one. And if you get that one, shit just gets nuts down here on this last one, and it will surely befuddle you. And then you'll have to come back, and I'll explain it. You'll be like, that was brilliant. I learned so much. Yeah. And I'll just stare at the camera for 8 minutes. Nice. Do you have to like, oh, there it goes. Cool, thank you. All right, I'm gonna, actually, this on. Right, people in the back hear me. If you can hear me, raise your hand back there, Malcolm. No, you can't hear me. It's, nope. Are they doing well?
I think most people are working on other things than
Oh, that's some bullshit. That's okay. Am I back on? I can like vaguely hear it. There we go. All right, so I'm going to now attempt to solve it for you. I don't know. I'll just grab that one. All right, I'm gonna try to solve it now. I can't tell if the speakers are on. Oh, those ones are. How about that? That one works now. Good news. All right, good news, everybody. I'm gonna go through that example that we looked at a moment ago. And so if you're stuck, this will hopefully get the answer. And if you're not stuck, or you don't want the answer, then you can totally just do one of those. We won't make fun of you, I promise. So let's look at this first one here. We're going to make a new W, and we're going to call the ZomaGod method up here. And what it's going to get called on is this object W, or it's an object whose class is going to be W. So when it goes to find the method, it's going to find that one right there, and it's going to have the string 1 plus WTF. WTF is a method call, and so this really is the same thing as that. And that means that the receiver is going to be our current object, our current self, which is W. And so when we go to its class, we wind up here again, and we find that WTF right there, and so we get 2. And so as a consequence, we should have 1 plus 2, and that will give us the string 1, 2, which is what we see right there. I'm assuming everybody can see the code. Okay. I saw a nod, so I didn't see any head shakes, so I'm going to call it a okay. Thank you. Next one we've got is this x right here, and we're going to call the same method on x. And so we're going to go look in its class, which is x, where we find the ZomaGod method. But it calls super, and the super keyword is going to go look in the super class. So that the super class of x, you can see is W, which will bring us up into here, where we'll find the same method that we previously had, except this time we called it on x. So we should get the string 1. I'm just going to put my prediction over here. A 1 plus WTF, which of course is that, and self is an instance of x. So we'll come here, we'll find that one, and we should find a 4 plus BBQ. Which is called again on self, which is our instance of x. So we'll come here, go there, go there, go there, and get a 3. So I'm expecting a 1, a 4, and a 3, unless I totally got it all wrong, or lied to you somewhere along the way. Good news, I didn't lie. Or if I have, we haven't figured out how yet. Finally, we get to the hard one here, the y. You notice I like to pick important, meaningful names. So we make a new y, and we can see the y inherits from the x, and the x inherits from the w. So when I call ZomaGod on that one, we're going to get a 6 plus whatever method would have been called if we hadn't been in the way, which is to say whatever, we'll go continue our search on at the superclass here, x, which takes us up to there where we find that one, which says go to my superclass, which is W, where we find that one there. So after the 6, I'm expecting to see a 1, and that one calls self.wtf, right there. Self, we know, is the same as this object here, because when I call the method ZomaGod, I called it on that object, and so when we made the binding, we set self to be that object right there. So we're going to go look for WTF inside of y. And we find it right there, where we have a 7. And then we'll go look at the superclass, where we'll find that method right there. So we should get a 4. Then we'll go look at the superclass, then we'll go invoke BBQ right self there. But this time self, previously self was an instance of x, but this time self is an instance of y, because I'm on this one right here. So I'm going to go start my search in y, where I'll find that BBQ, find the BBQ of the superclass x. I find that one, which says to go back up to the superclass, which is w, where I find that one. So 3, unless I messed it up. Did I mess it up anywhere? 617483. There we go. There we go. So now we were able to trace the method calls all the way through based on the fact that when you call a method, self inside of it is always going to be the object that you called it on. If you liked that one, or alternatively if that was too much, the good news is there's a whole bunch more challenges here in this directory, many of which are simpler. I just think that that one's the fun one that really kind of pushes the boundaries of what you can think through based on other patterns of making sense of the world. So you can try any of these as well. And since I'm trying to complete this by 1:30 so that you all can go about your lives, I'll just tell you that the singleton, if you think of inheritance as a linked list, which is to say a class has methods in a superclass, which has methods in a superclass, which has methods in a superclass, then the singleton class is what happens when you insert a node at the very head of that list. So for example, main, it will tell us, is an object. All right. Self, which we're calling main, is an object, but you can see we got this weird thing where if I call inspect on it, it returns to me the string main, and that's not what objects normally do. And so then the way that we're going to pull that off right there, the reason why it says main when I look here is because we stuck a class at the class pointer before object. We inserted one at the head of the list. And what that one's going to tell us is I'm a class whose sole purpose in life is to make methods available to this object here. That object is main, just it's the other inspect. It's if you called super inside of inspect, you'd see this one here. And so if we said, well, if you're a class, we know how to think about classes, right? Classes have methods, and they have a superclass. If what I just said is true, we should see a method in there that makes, we should see the inspect method in there, which is what makes this work. And that's what we see there. So when I call inspect on self here, I'm going to invoke this method right here, which is just defined to return the string main to me. That's why I see this thing. If I put a different method on there, if I replace that method, it's just a key and a hash, I can just go in and say, well, point that key at something else. Then all of a sudden, I'm not in main, I'm in not main. Love. Okay? So the way that this thing works here, or what people call class methods, it's just this class at the head of the list whose superclass, in order to not break all the other stuff that you used to be able to do, they set the superclass to be the original class. So in this case, we see that the class is object. And so if I go to this method here is it's line view. It's actually seeing the singleton class and then skipping past it to the original one. So if I look at the superclass of the singleton class, then I'm going to get object there. And then just to iterate, because I feel like this is a little bit, it's not good enough, we'll pick a string here, okay? Like that. And so if I go to its singleton class, which is just one node in the linked list before we hit string, then to continue on where I used to be, the superclass has got to be set to string. So go here to look for methods on this object, and if you don't find them there, go to the superclass, which is string, and then at that point it behaves like every single other string ever. All right. I should do that way. That way it's easier to see. So reverse does work unless I get in the way, which is what I'm going to do right here. And now when it goes looking through that linked list, it no longer finds the reverse method from string, and now first finds the reverse method from the Singleton class. So that's how Singleton classes work, and I'm out of time, so I can't tell you about how modules work. But I'll probably chill here, so if y'all are super curious, I would love to share. All right. Cheers. Why do you think they'll stay there?
Thanks a lot for coming out, everybody. That's it. We typically hang out here in the afternoons and work on open source stuff. This is our Waza time practice, so feel free to stick around and chat about 8th Light with anybody you see around here. So thanks, everybody. Keep in touch on the meetup group.